This is a lecture for Math 107 on break-even analysis. Break-even analysis is a way to look at your cost, revenue, and profit in a business. We're going to start here with just linear equations. In the last half of this chapter, we look at quadratic equations in break-even analysis. The variables that we deal with are revenue. Write that with an R. Well, first X. X is going to be the number of items sold. If you have a consulting business, that might mean the number of hours billed. So it can be that it's just a quantity of work that you do. So we're going to say, for simplicity, that it's the number sold. Well, later on there's an example. If you had an apartment building, it might be the number of apartments that are rented out. So that's what X is. Now, revenue is the money that you bring in. It is a function of X, and it is the price, or the cost you charge, the price you charge a customer, times X, times the number sold, or the number rented, or the hours billed. For example, if you have items and you sell them for $5 each, revenue would be, the function for revenue would be 5X. Revenue is simply the money you're bringing in. Of course, this is a simplistic model, but we have to start somewhere. Now, costs are broken into two pieces. They also depend on the number sold, but you have the fixed costs that don't depend on the number sold. This is your rent. So I've got fixed costs, and then you have variable costs. The fixed costs, again, are your rent, they're a manager's salary, they're bills that you have to pay whether you do business or not. It doesn't have anything to do with the number that are sold. It's just what your monthly, we're going on a monthly basis, this is your monthly fixed costs. Alright, I'm going to write them as CF for fixed costs. Now the variable costs depend on the item. If you have to go out and buy this item you're selling for $5, if you have to go out and buy it for $2, then the cost per item is $2. So the variable costs are 2X. It's the price that you have to pay for each item, or the amount of money that you have in each item that you go ahead and bill your customers. Well, this is sort of mixed here. Let me try to clean that up a little bit. So this would be your variable cost times the number. We're assuming you're not storing anything, you're buying things and selling them. You don't have a storage issue here. Well, you might. It could be wrapped up in the variable costs. But let's give an example here. Let's say your fixed cost, the rent that you pay, is $600 a month. Well, the $600 goes here. It doesn't depend at all on the number sold. It's what you have to pay no matter what. And then let's say you're buying these items for $250. So it'd be 250X. And that would be your cost function for this particular business that we're talking about here. So we have X, number of items sold, R is the revenue, the money I'm bringing in, C are the costs to do business that have two parts. One is fixed cost, that has to be paid no matter how much business I do or don't do, and then the variable cost is the cost per item that I'm required to pay in order to sell them later. Okay, there's another variable called profit. It depends on the number sold too. And profit is the difference between your revenue and your cost. Now this gets a little tricky based on proper distribution of that negative sign. So I'm going to write out what we have for the business we've got right now. So that's 5X minus, now this is minus all of the costs, minus 600 plus 2.50X. If you forget the parentheses, you better have a 0 in front of the variable cost. So this is 5X minus the fixed cost minus the 2.5X. And people forget this all the time. They forget to subtract off the variable costs. I'll show you how that's done. They use this and write, okay, 5X subtracting my costs, minus 600 plus 2.5X. That's what they do, and then you end up adding the variable cost into your price, so that'd be 750X minus 600, when it should be 2.5X minus 600. Okay, I just want to point that out. I'm going to write these equations again just so we can look at them. So R is 5x, C is 600 plus 2.5x, and then the profit is 2.5x minus 600. And what I'm going to do now is I'm going to graph these equations and show you how this works. Note that profit could be negative. When we speak in ordinary terms, we tend to think that profit means a gain. It doesn't always mean that. Okay, so this is going to be my x-axis, and this is going to be my money axis. I can graph all of these on the same axis. I'm going to look first. I'm going to evaluate each one of these functions when x is 0. When x is 0, the revenue is 0. So my revenue is going to be 0. All right. What is the cost when x is 0? It's 600. So the cost starts up here. And what is the profit when x is 0? The profit is down here at minus 600. So this is 600. This is minus 600. All of these numbers start out like this. Now there's a point where these numbers cross. I'm just sketching this out here. Okay, let's say here is my revenue function. Okay, like that. And my cost function. Notice these are linear functions. A linear function has a slope. We call the form y equals mx plus b. Whatever's multiplying x is the slope. So the slope here is 5. Slope of the revenue is 5. The slope of the cost function, make some room. Slope for the cost function is 2.5. That means they're both increasing as x increases, but the cost function is increasing slower. It is a flatter curve. So I'm going to go back here and draw the cost function. Now it's going to have its slope isn't as steep as the revenue. And so they cross. These lines are going to cross, and this point right here where they cross, this value of x is called break-even. Well, actually the whole point is called break-even, but generally we just refer to it, the x is break-even, but you really need to know this other number as well. So there's some value of money where the cost, the revenue have exactly the same value, and at some value of some number sold, you will get to that point. Okay, that was not said very clearly, so let me try it again. The point where these lines cross is called the break-even point. The x value of that point are the number of items that you have to sell in order to break even. In other words, you have to sell that many items so that the money that you bring in has covered all of your costs up to that point. It's covered your rent, any other fixed costs you have for that month, and it's also covered the cost of all the items that have been sold. Let's look at the profit. Profit is the difference between those two numbers. It's starting at minus 600. And what is a profit when revenue and cost are equal? It's 0. So here's your profit. Actually, slope should be 2.5. So I didn't do a very good job of drawing this graph. But the idea is here. At the break-even point, the profit is 0. Up until the time you hit break-even, you're operating at a loss. This region in here is a loss. Once you have hit break-even and you go on and sell some more, then you have a gain. This is what it looks like graphically. Algebraically, we're trying to find x such that the revenue and cost are equal. We find that algebraically, and then we know this point. And this is the kind of graph that we'll draw. Let's change the numbers a little bit, and I'll work out the example that was done in the lecture notes so you can make a comparison. In that case, the revenue was 5x. That means the selling price is $5. X, again, is the number sold. The cost is $600, and each item costs $2 for you to obtain. The $2 might reflect the cost to manufacture the item. It's not always about just buying the item. The profit is revenue minus cost. When I work that out, I would have 5x minus 600 minus 2x would give me 3x minus 600. Right. Now I want to find the point where revenue equals cost. I'm looking for that break-even point. To do that, I set R equal to C, or you could set profit equal to 0, but let's just do R equal to C. So 5x equals to 600 plus 2x. Obviously we have 3x equals 600, x equals 200. This means I have to sell 200 items to break even. Right? What are the revenue and cost at that point? They're equal, of course. The revenue at 200 break even would be 5 times 200. That'd mean I'd have to bring in $1,000 in order to cover my rent and to cover the cost of items I've sold up to that point. So now I'm going to graph this situation. Say that's 500. 750. Not a very good scale, but that's okay. I excuse it for myself, but I don't. I'm kind of harder on you guys. So it'd be 250 minus 500 minus 750 minus 1,000. All right. The revenue when x was 0, revenue equals 5x. Here's my money axis. And after I'd sold 200 of these, say 50, 100, 150, 200, so here's 200, this is the number sold, then the revenue would be 1,000, and this is my line through those 2 points. Okay, that's a revenue. Now we can graph the cost function, pretty easy. It starts out at 600 because that was the rent, and it also goes through this point. It goes through the break-even point. So I can draw that graph by doing this. And here's the cost. Now let's look at the profit. Profit starts at minus 600. I don't have a dot. Let me get a dot here. It starts at minus 600, and at break even at this 200 mark, I have to kind of make it big. All right, the profit is 0. And here is the equation, or here's the graph for the profit. Okay, profit is 0 at break even. Revenue and cost are equal at break even. In this case, the break even was 200. And at that point, the revenue and costs were both equal to 1,000. Okay. In this region, prior to break-even, so to speak, you're operating at a loss. Once you cross break-even point, you're operating at a gain.